Hey guys, welcome back to the Garod 15TZ6 restoration project. I have a bunch of updates for you guys. I want to start out with showing you what the front of this looks like with all the knobs installed, because when I got this home it was disassembled. I went out to the garage and I got the knobs out and popped them on. Basically they're RCA type knobs, but they've been painted gold. Nice touch, except for the channel selector. That is uniquely Garod, I do believe. What's especially odd is how this tuner works. I didn't pick up on this when we did the initial chassis examination. This is a variable capacitor tuner. So I've shown you continuously tuned Dumonts in the past, and a Strumper Carlson more recently, where they use roller inductors, and it's a continuously variable knob, and you can get part of the, you get the FM radio band in between channels 6 and 7, along with the TV channels. This is also very continuously variable tuning. If I pop the roller out for the detent on this, this would just rotate freely, and it would, you could get the whole FM band, and it would go between the TV stations. But they put notches in this disc behind the channel to stop it. So it has rotor plates underneath this tuner just like the radio does. But imagine like this radio had notches in here and it would just lock into certain stations. Now, unlike a big old channel clunker with switchable sections, though those have adjustable slugs for each channel, so you can do a fine tune on the local oscillator for that channel. You don't get that with this. This has all got to be mechanically set up perfectly, or you're going to be off. There's no way to make individual adjustments for each channel, at least not that I can see. So, very curious to see how well this tuner works in practice. Let's start out with this large flat package, which should be a copy of the Sam's Photo Fact for this set. Oh, I really hate these mailers. Not easy to get open. You don't want to damage the contents inside. Alrighty. So, yes. So this is the tabletop version. They used this chassis in every model they made. They made a 10-inch, a 12-inch tabletop, of course the 15-inch console, and they made a number of different console versions. They all use this chassis. You can see the knobs there look awfully similar, don't they, in the same dial and everything. And that's why it's shaped like this on the front. And that's why we've got these rubber pads. So this is the tabletop chassis. The picture tube would sit right here and rest on these points. They just left it like that for this console version, in which where the picture tube is would sit over here. Alright, so we're going to have this to work off of, which is great. Let's look at this next, which is going to be a whole bunch of capacitors. Now, I do have another order that's on the way. It should be here in a day or so, which will be the power resistors from Mauser. I went a little overboard because, well, it was going to be a special project, so I got some Sprague Atom electrolytics, which are horrifically expensive, and some very nice vitreous enameled resistors. But for the paper caps, or at least for some of them, we're going to be using, the yellow axial caps. That's kind of the only game in town these days. So I got a bunch of those from my guy in Milwaukee that I've been buying caps from for a few years now. Haven't had any trouble. They're good quality caps. In this last bag, are you ready? Are you ready? Huzzah! We've got a whole mess of adapter caps. These aren't the usual adapter caps, so let's talk about it. If you've been watching any of my restoration projects over the last couple of years, you've probably seen me use something called an adapter cap. That is an aid to replace multi-section capacitors, such as these, with modern capacitors. It's a little circuit board, like so, with mounting holes that line up with the larger style. This is just on a little holder with sort of like a business card. When you pop it out, they look like this, and they mount down in these holes where there were once rivets to hold these down. Put in some screws there, and you can mount up to 4 capacitors here, and you get pads to attach your wires, and there are a couple of configuration modes. By default, these outer terminals, the ones you screw onto the chassis, are isolated, meaning these capacitors and the negative leads are not connected to this. But there's a jumper wire, so you can. So these are both for isolated or grounded to the chassis type configuration. Now I could use this style for 1, 2, 3, but notice these two are smaller. And also, as we discovered when we were looking at these, each one of these only had a single capacitor in them. Even though they're this large, because they were fairly large value capacitors, 82 microfarad, 500 volt capacitor for this guy in particular, the one that failed. Well, the gentleman that runs Adaptacap has sent me some engineering samples in the past of other styles. And I had run out of them, and I knew I was, or I would have liked to have used them for this project. So I asked him, hey, do you have any more, and can I buy them? Well, he generously gave me some more samples, but also, if you go to the Adaptacap website, he now is selling those other styles. What are the other styles? Well, smaller ones that will fit in this in the smaller size, but also ones that only have a single section. Both the smaller size and the larger size. I've got some somewhere around here. Here we go. The larger single section variety for 1, 2, 3. So, and I've got a single for this guy as well. So, that is what I am going to be using. The advantage of using the single ones when you're only going to have a single cap is you don't have to worry about all these unused terminals that kind of get in the way. When you've only got a single cap on there, you get nice big lugs with plenty of insulation around them. And in particular for this guy, the one that vented, larger size for that, I needed a 500 volt cap. So I've got this nice 82 microfarad 500 volt cap, but it's the type that snaps into a circuit board. Well, it fits perfectly into this. And then we can mount it right down, and they look like that. Now, I know some of you are not crazy about losing the authentic look and feel of having the circuit boards and the modern caps exposed. Well, for the ones that were covered in cardboard, if you're careful, you can remove that cardboard cover. They're usually held in with a little glob of glue on the top or on the side, a little bit of heat, or in this case, over time, the adhesive had just failed, so they just came off. You can do that. Put some, even just some like styrofoam packing peanuts or something in there to give it a little bit of, to grip onto that. So that's one option. Well, what about the metal cans? Well, you could fabricate one if you got some aluminum stock. You could take the old cans like this and cut them up and try to glue them down or something. But hopefully in the near future we'll have a better option, because the guy who runs the site is working on getting some aluminum can covers that will be compatible with these. I haven't seen the final, or I haven't gotten a prototype yet, but I'm sure they'll be set up something with tabs or something like that, so these will actually fit down securely. So one of the reasons he gave me some samples of these was to talk about this, because he's using the proceeds from recent sales to fund getting those prototype cans made, and ordering up some aluminum stock and whatnot. So as you know, again, if you've been watching my videos, I am a huge fan of these, especially for the caps that are mounted on phenolic wafers like these were, because the negatives on most of these caps does not go to the chassis. So you want to keep it isolated, and that's exactly what these do. Unless you put a jumper in, that's what this lug is for here. The negatives on this little board here do not go to the chassis. It's perfect for this application. I mean, this is what these were made for. We had 5 of them to replace. These line up beautifully, mount the single caps. It's just wonderful. So if I didn't use these, what would my options have been? I could break off the covers, saw open the caps, take out the insides, drill holes, run leads down, glue or otherwise secure the top back on. That's a ton of work. Leave them in, cut the leads off, drill holes, mount terminal strips, relocate the caps underneath. Also a lot of work. You have to reroute the original wiring. This wiring is really brittle. It's also very, very neatly laced wiring. I don't want to alter it. So this is a fantastic solution. So I highly encourage you to give them a try. And if you're working on anything like this, especially these sets like Motorola, the 7-inch sets with the TS4 and TS18 chassis, these are also fantastic for those. I've shown those in a few projects. As those are also all isolated from the chassis, and it's really dense wiring and it's hard to rework. You need 3 of them, bam, 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 works out great. So I'll be making really quick work of this. Now notice how clean it is too. That's why I wanted to get those caps out. Lacquer thinner, just removed everything, except you can see a little bit of discoloration around here. That's where that cap vented and deposited some stuff. If I used some metal polish, I could probably get that out, but I'm okay with it just the way it is. My only regret so far is I wish I had realized how well these snap type caps work with these, because these are readily available and you can get 500 volts, really good specs on these because these are used in modern type equipment. But I had never used, I didn't use them in the past because you just get these short little stubby leads, and I figured they wouldn't work well with these vintage sets. But with these boards, yeah, absolutely they do. All right, tuner. So that is the tuner. See these metal slots here? Those are variable capacitor plates. And as I turn this, you see that there are plates moving around. Now because these are much higher frequencies than, let's say, an AM radio, there's very little. A lot of these is just 2 pieces of metal. Just 2 plates of the capacitor and that's it, or there's 2 plates with one in between that's moving, and they're not like fully meshed. There's just little parts of it that are overlapping. It's for the higher frequencies. So neat thing. But again, fingers crossed that it will work just as is without me having to do a whole lot of work to it. I do need to lubricate it though. I don't want to monkey with it anymore, rotating it around, because it's a little stiff and I don't want to damage anything. Alright, so what is going to happen next? Alright, so what's next? I still wanted to try doing a power-up before I replace everything. My initial thought was, oh, I'll just replace these 5 electrolytics and then get it on a Variac and do a slow power-up, but I can see so many parts are so degraded. Paper caps just oozing wax. Power resistors that are fried. I think I'm going to end up doing more work than I would normally do before I do a full power-up. But at least I want to try doing a power-up soon with the rectifiers pulled out, just to get the filaments to light up, including this little nifty light that goes above the phonograph so you can see what you're doing when you swap out a record. And check the secondaries to see the transformer's not shot. My concern would be that because this one or more of these electrolytics just failed miserably, I could have taken out the power transformer. We can see wax is oozed out. And I might be thinking, well, you should check that first before I do anything. Why am I buying all these parts already? Even if this is fried, I'll get a replacement. This set is going to get restored come hell or high water. I will get a replacement picture tube. I will replace any of these parts that are bad. I'm willing to go to that length. I want this set to live again. But it'd be nice to know sooner than later if I need to start tracking down some of this harder to get stuff. So let's talk about actually using these in practice. Typically, I install the caps, then mount it to the chassis, and then hook up the wires. But sometimes I'll mount it, hook up the wires, and then install the caps. It kind of depends on how tight the area is I'm working on and how the wires are routed and so on. Let's start out with a single section. That's easier to work with. For one, you've got a bunch of mounting holes. So depending on your lead spacing on your capacitor, you've got a whole bunch of options here. Let's use one of these bigger ones. I think this has 7.5 millimeter spacing, whereas the skinnier one has 5 millimeter spacing. You want to take the sides as adapter cap, and that goes against the chassis typically. And you put your cap on this side, and I'll just use the middle holes there. Might want to spread them out a little just to keep it stable while you're soldering. And then just solder like you would anything on a circuit board. Heat up the foil a bit, hit up the leads, and feed the solder in. Now the center slot is generous, so what I'll typically do is solder it up on one side, and then get a bit of a blob on the tip of the iron, and fill in the hole on the other side like so. Do this guy as well. So why are those wide slots there? Those are to accommodate larger caps like the snap-in type, which I did use on this set. I'll show you that in a bit how that worked out. And snip off your leads, flip it over, mount it to the chassis, and then to hook up your wires. So these holes are not only to accommodate the capacitor, but when you want to hook the wires back up onto the chassis, of course you can use those as well. But they'll be coming in from the bottom, not from the top side typically. So I'll strip the wire back just a little bit and get it so it's in one of these holes, and then solder them up. Now for the multi-section, you have much tighter spacing. The holes are designed for 5 millimeter spaced caps. Call these pencil caps, skinny caps. Readily available these days. I'm not sure what they use them in, but I'm glad they still make them. So 450 volt skinny caps. Widely available, readily available, long life, 105 degree temperature, low ESR, good stuff. But the old fatter caps, I was just looking on Mauser, you can get them up, the snap-in especially, you can get up to 750 volts. Yeah, they're $10 a pop, but you can get them. So 500, 600, 700, you can't get high voltage caps in the skinny variety. Anyway, these mount, same deal. The adapter cap goes down, and remember the jumper. So by default, these outer ears are not going to any of these capacitors. They're floating. But if you do want to ground all the negative leads to the chassis, you install a jumper right here. On the flip side, it says frame. You want a jumper from the minus to the frame. That where it says frame, that's going to this, and where it says minus, there's a ring around the outside. That's your negatives. All your negatives go to the outside, all your positives are towards the center. So when you install your cap, you want to put it positive lead in the positive, negative on the negative, and notice there's a slot between them. That is to provide additional insulation. FR4, I assume these are made out of FR4 fiberglass material. It has pretty good dielectric strength, but having an extra slot here just gives you that extra bit of insulation. So feed them through, bend over, solder up. The extra holes there are to accommodate somewhat larger caps, or the wires we're going to be hooking up to this as well. Solder it up, 1, 2, 3, 4 sections to whatever you need, and then mount it in and hook up your wires. And here's how it turned out on the top side of this set. That's why I was so psyched about using these, because all 5 of these are isolated from the chassis. These line up perfectly, and they're all single section. And this is a big old snap-in, so that's a 500 volt cap. That's the cap that vented, so I used an extra beefy cap there. Now I still need to wire them up. As far as mounting them, I use those cap head screws and the nylon locking nuts. It worked out great. Here's what we have on the underside. So now we need to hook these up. This is where you really should have taken a bunch of reference photos, and it's helpful to have a good schematic and understanding of what cap is where and what wires are going to what. I clipped off the lugs from the old caps. So for example, this is the entire lug of that old cap. I want to get rid of that. Sometimes, especially with the 4 section, I'll leave this on, especially if there were, like, say there were 3 or 4 wires going there. I'll leave most of the lug there and tin it up and just solder the entire lug with all the original wires exactly as they were right down onto one of the pads. But in this case, we're just talking a single wire, and all we need is just a little bit of a stub left on it. So I'm going to cut this off, heat this up a little bit to melt off the rest of that lug. Sometimes this old solder doesn't want to cooperate because it oxidizes, but there we go. So we just have this little stub left, right? Here's a close-up of the bottom of that cap. Now I want to attach this orange wire to one of these 4 pads. To make your life easier, tin the end of the wire and feed some solder into the pad that you decided you want to go with. And then all I have to do is take my wire and heat up that pad, and there, I'm done. That's all you gotta do. Now be careful, because what's right on the other side of that board? The bottom of your capacitor, especially if you mounted it flush like so. If you're aggressive, you stripped off a bunch of wire and you shove it through that hole and heat it up, you could potentially melt through the plastic on this and touch the aluminum can that's encasing it. In the case of the multi-section like this, you could, it'd be difficult to do, but there is the potential you could short some of the sections together. So either be careful when you solder or when you mount your cap. Don't put it flush on the board. Leave it 1/8 of an inch, 1/4 of an inch proud. Well, aid in ventilation as well. So that's really all there is to it. Take reference photos, follow the schematic, and I don't think you'll have any trouble. And after I hook these up, I gotta also attach this ground braid, and there's a few nuts I left out while I was moving the wires around, but I will have this done in short order. It really speeds up the process. Hey, right on time. My Mauser order has arrived, so let's pop it open and see what all they sent me. So this should be everything else that we need to complete this project. Assuming something isn't tragically bad. Good old Mauser. Inside of each one of these giant bubble wrap things, probably 1 resistor. You know, I can't knock them. I imagine a lot of their orders are placed by places, actual engineering firms that are building prototypes that may lead to future bulk orders. So, actually, no, these are just electrolytic caps. Okay, that was totally unnecessary. But they do, yeah, so this will be a single resistor. Yeah, they are fragile. If there were several in here, you wouldn't want them smacking into each other. The enamel coating would chip, potentially. Well, this isn't quite a vitreous enamel. It's, I think they call it silicone coated. This is one of the 10-watt guys. Somewhere in here, we better have some nice big old Here we go. Here's one of them. Ah, I see. Yes, they're in bubble wrap, but they're still in the original manufacturers. They put them in cardboard boxes. I'm wondering where the heck these guys are hiding. These are the most expensive things in here. These are the most fragile things in here. There we go, yes. In case you didn't know, Domite is still making these exactly like they did back in the day. A venerable series of power resistors. So it should just fit in there perfectly. But it's in much better condition than the one that's currently in there. There should be another one in here somewheres. Yeah, there it is. And this is the one I got. So one of them is 17.5. I cannot get that. Yes, they still make these, but imagine they're not used that much. I'm grateful they make them at all, but the values available are rather limited. So I got a 20K. It's the closest I could get. I think it goes 10K, 15K, 20K. That's all you get. So there's no 18 that would be close to 17.5. So we're going to take a 20K. We're going to parallel it with something. I'll have to get out a calculator and figure it out to knock this down to 17.5. But I should be able to reuse the existing mounting hardware, I hope. Oh, what else of interest in here? Oh, yeah. They ain't cheap, but I figured since I was doing this, well, why not? And splurge that often on Sprague Atom caps, but I saw they had some in stock, so I got some, 5 of them, 2 10s and 3 5s, I think, because there are a bunch of axial electrolytics down below, so I got some good old Sprague Atoms, which I think are still made basically for the audiophile crowd. Axial electrolytics aren't made much anymore, period. And especially in oddball values like 5 microfarad. That's not standard, 4.7 is. But they cater to the old-timey crowd, so yes, you can still get these. But they're like $6, $7, $8 each. So yeah, like I said, I'm having fun with this. I'm going a little overboard because I want to. In this giant ball of bubble wrap here, we have the 2 8 microfarad Sprague Atoms. Look at those. I was kind of curious to see what they would look like too. I say that because here are some relatively recent production Sprague Atoms, and these are bright orange, 50 microfarad, 450 volt. But obviously the ones I just showed you are black. I think these are too. Yep, there we go. So nice. No need to add terminal strips or have any trouble. We got nice long leads. These will go in just like the originals did. Just about done wiring the caps in. I'm down to these 2 guys. Let's talk about them for a minute. Notice that red wire going from the positive on top to the negative on the bottom. Those are the 2 80 microfarad 350 volt caps that are wired in series to increase the effective voltage rating. That's these 2 caps on the schematic, C1 and C2. A couple 80 microfarad capacitors wired directly in series, no other components. And why would you do that? Well, capacitors have a voltage rating, and when you exceed that, they break down and they fail. So, they needed a capacitor that had higher voltage rating than I assume was readily available at the time. This capacitor comes right after the rectifier. It's going to be the highest voltage potential point in the set. And when the rest of it is cold, when you first turn it on, it's not drawing a load, this voltage is going to be especially high. So they took a couple 80 microfarad 350 volt caps and put them in series. Well, what does that do? What does that mean? Well, think about a really simple capacitor. We got 2 metal plates. The voltage rating is the voltage at which the insulation between the 2 plates starts breaking down. So how do you increase the voltage rating on a capacitor? Well, one way is increase the distance between those 2 metal plates. When you do that, the capacitance goes down. But think about it this way. They took two capacitors that had plates like this, and they put them in series, so you got this, then another one, which effectively doubles the distance between the two outer plates. So that turns our two 350 volt caps into a 700 volt cap. However, when you increase the distance between plates, the capacitance goes down, so we lose capacitance. We lose half of it. So the two 80s become a 40, and the 350 becomes 700. In theory. We live in the real world where nothing is perfect, including these capacitors. It's not going to divide the voltage evenly between them. They're not going to have exactly the same characteristics. One will have slightly more leakage current than the other. Capacitance could vary a little bit. There is a way to compensate for that, which they chose to not do for some reason. Not sure why. It's really inexpensive to do and really simple, which is to add two resistors, one across each cap. Call them equalizing resistors. They form a voltage divider. And if the voltage divider current is much larger than the leakage current in these, that's going to drive the dividing voltage. So if we use two equal value resistors and put them across there, that will take care of our issue. Now the value, well, that's a bit of a, I was going to say black art. It's not so much that. It's more experience and knowing the characteristics. So if we knew what the leakage current is, say we want to eliminate that as a factor, so we want to have the current through our resistors be maybe like 10 times what the leakage current is. But I don't know exactly what the leakage current is. I could look it up on the spec sheets, but again, it's going to vary with the capacitor's age, and there's going to be a certain tolerance range and all that, and how well it forms up when the set's powered, and how long it's been sitting since it was last powered, and so on and so on. But a good rule of thumb is between 100K and 330K. I'm going to go with like 180K, and I already did the math, and I think it dissipates 3/4 of a watt. So I'm going to use a couple 2 watt or 3 watt, 180K if I can find them. I can see, digging through my parts here. For sure I got a couple 220s, for sure I got a couple 150s. I was really hoping to use 180. And there we go. I ended up going with 220K 3 watt because that's what I had on hand. Now what will the current be through those resistors? Well, assuming there was 220 volts across the cap, it'd be a milliamp. I don't know what the final B plus is when the set's warmed up, but I'm guessing they'll be in the neighborhood of 1 milliamp going through each of those resistors, which should be a lot higher than our leakage current. These are good, healthy capacitors. Alright, so that is just about it for that. Let's wrap up this video by doing a power up for the first time. So I've been trying to figure out, where does the AC go when it comes in? These caps here, it's hard to say. Yeah, I gotta trace this out. So where the AC line comes in, there's a glob of wires and they're going up somewhere. I thought maybe they're going right over to these caps, but no. I'm not sure. I'm not sure. I know there are supposed to be some caps across the line. I want to get those out. I just got to figure out where the heck they are before we can plug this thing in. Well, it's turning out to be a little bit more complicated than I expected. I forgot that this down here is not where the AC power comes in. It's not an AC interlock. That's where AC power goes out. I think that's where the phonograph plugs in. That or the audio amp. The AC line coming in, there's just a hole in the back of the chassis, and I forgot that I had clipped it off because it's just the insulation was disintegrating. But I left a stump of it there, and one wire goes to this terminal, and one goes up here. Now, with the set turned on, and we do have continuity on the power switch, we should, I'm going across the power switch terminals there, we should have continuity between this because it'd be just going right to the primary on the power transformer, and we do not. Now, one safety feature this set has is it does actually have a fuse, and there's two fuses, one for the flyback and one for the entire set. That's this guy right here, and I'm sure you'll be shocked to learn it is dead. I can see it's blown open. Looking through the side. Let's see, what was this? It's a 5 amp fuse. So 5 amp fuse blew. So when that capacitor vented, I'm sure it shorted out and drew enough current through the transformer. 5 amps on the primary, that's like over 600 watts or something in that ballpark. That's a lot. I was looking to see like a 2 amp fuse in here, not a 5 amp. Anyways, let's pop in a new one. I'll put in a 2 amp and see if we get continuity through the primary. Then I'll dig up a power cord and rig it in. So I won't be, I'm used to using cheater cords with an AC interlock on them. I'm going to have to find a power cord that just has bare wires. So I'm used to plugging one of these in, but I can't do that. I gotta just have some bare wires on the end. Here's a nice 3 amp fuse. Let's pop that guy in. For continuity, first on the fuse. Yep, it's a good fuse. And now across the AC line. That's good, so we don't have an open primary. Let's check the resistance, make sure it's not a dead short. 82 ohms, 81 ohms. I don't think they stayed on here where it should be, but let's find out. So, time to find a power cord. Alright, new power cord installed and plugged into my Syncor Variac. Sets turned off, Variac's turned on, output voltage about 117. We'll put in current monitoring mode, and here we go. Alright, so not a dead short. Drawing 3/4 of an amp. Now the rectifier tubes are out, so we're just talking. Tube filaments. And yeah. Yep, they're all lighting up. What's not lighting up though are any of the lamps. One is for phonograph and the other is for radio, something that has to do with the mode. One of these will be the mode switch. Gotta be this guy. Oof. Oh yeah. Hey. A little bit of a delayed reaction. I'm thinking that switch is dirty, but I'm more shocked that those bulbs are still good after all this time. I'm also curious if we go into phono mode, will this light up? It is AM and FM. Oh. Yes. Phono mode. Radio mode, radio. There. TV mode, radio mode, other radio mode, phonograph mode. That switch definitely needs a good cleaning. Alrighty. Alrighty. I'm going to leave you off with one last thing. There's another chassis I haven't shown you, which is the audio output amp, which is its own dedicated power supply. But before we do that, let's check the secondary voltages. So let's go to pins 4 and 6 on the 5U4. Those will be the plates. 1, 2, 3, 4, and 6. 772, that seems perfectly reasonable. And on the 5Y3, it's the same pins. 1, 2, 3, 4, 5, 6. Makes perfect sense. Lower voltage for the lower rail. Alrighty. Unloaded, of course, but I'm feeling good that power transformer is alright. Alright, here is the other chassis. Just audio amp standalone. So, power transformer, filter cap, 5Y3 rectifier. I think it has, twin 6V6 push-pull output. I think that's a phase inverter, 7-pin tube. It's missing. I'll have to figure out what's supposed to go there. Now remember, this chassis is for a tabletop set, so this is very much cobbled together. I think the way this went is this plugs into that socket in the back of the TV. And then the TV is hardwired with a cord and that plugs into the wall. and somewhere power gets fed into the turntable. We'll figure that out when we get to it. And these plug into the two 10-inch speakers that are still in the cabinet. Now, how do we get audio into this? So that's the amusing part, I think. So this chassis they used in all their models, and mostly they made tabletops. And normally that empty socket right there is where the audio output tube would go. I think it was single-ended 6v6. Well, for this, they cobbled together this octal plug that just has one wire going to it, and that plugs in there, and that's how they get the audio signal from the main chassis to the sub-chassis, which is very, very much oxidized cadmium. Underneath, it's a bit of a mess. It'll be a filter choke, a bunch of paper caps, all original power resistor. Everything looks pretty roasted and needs work. And I just noticed there's a plug on the side. I bet that's where the phonograph plugs in to get power. Hey, what do you know? They kindly provided us with a little tube label on the side of it. Tube label amplifier unit. The missing tube is a 6AT6. And yes, that is the phono power outlet on the side. Alright, I think that's enough for this video. I'm going to get busy with rebuilding the power supply, that messed up area here. I've dug up some good rectifier tubes, and hopefully in the next installment we will try a controlled full power up. That's it for now. Thanks for watching.